Hello, my name is Fatiana Jones. From my name, you may have assumed that I am related to Indiana Jones. This is quite correct. Indy is my older brother, and he got the cool nickname. I was just a chubby younger brother. Kids can be so cruel. Unlike Indy, who is an archaeologist, I am a physicist, and today we will be talking about quicksand. The question of the day is just how dangerous is quicksand? What is myth and what is reality? We came to the jungle today in search of quicksand and to clarify the misconceptions about this force of nature. We are in a muddy and watery area of the jungle. These conditions are common for areas with quicksand, though quicksand can occur anywhere if the conditions are right. Now let's go find some quicksand. The quicksand must be around here somewhere. Quicksand is usually created when underground water seeps up, saturates the sand, and reduces the friction between the individual grains of sand. This in turn liquefies the sand. Regular sand can support large amounts of weight due to the friction between the grains of sand. It creates a force chain, which distributes a load across a large area. If you have sufficient moisture, the sand and water form a suspension where the sand particles are now floating in the water. Because the friction is reduced between the grains of sand, it can't hold the weight as effectively. Because the water is from an underground source, the top layer of sand is usually dry, so quicksand usually looks like normal sand. Ah, there it is. As my explanation hints at, quicksand is both a solid and a liquid. When quicksand is at rest, it thickens over time. This is why it appears to be solid. Quicksand is, however, very sensitive to small variations in stress. Thus, when you put the quicksand under stress, the quicksand liquefies very quickly, which means that moving around more will cause the quicksand to become more fluid, and you begin to sink. Now that I've told you a little bit about the properties of quicksand, I will explain what would happen if you got stuck in quicksand. Unlike common mythical quicksand, real quicksand will not pull you completely under. It's practically impossible. This is because of the density of quicksand and the buoyancy of humans. Quicksand has a density of about 2 grams per milliliter, while humans only have a density of about 1 gram per milliliter. Because the density of humans is smaller than that of quicksand, humans will not completely submerge, but instead float like a cork in water. This occurs due to a concept called buoyancy. According to Archimedes' principle, which states that the upward buoyant force on an object in water is equal to the weight of the displaced volume of water, humans should float in quicksand because they have a lower density than quicksand. Given the difference in density, humans would sink to about their waist, but they would sink no further. Now you may be thinking, if you can't completely sink, and quicksand becomes less viscous as you struggle, then why is it so hard to escape? After initial liquefaction, the quicksand splits into a water-rich phase and a sand-rich one. In the sand-rich phase, the sand sediment becomes densely packed and the quicksand's apparent viscosity or thickness increases. The dense sand sediment has a very high viscosity, making it hard to move. The amount of force needed to pull out one's foot from quicksand at a speed of 1 centimeter per second is said to be equal to the force needed to lift up a medium-sized car. So, if you happen to get stuck in quicksand, I have some important advice for you. Do not flail around because this only causes you to sink deeper due to a sucking effect. There are 2 techniques to escape. The first is to slightly wiggle your legs around in order to create space between your legs and the quicksand. This allows water to flow into the space and loosen the sand. Slow and gradual use of this method will allow you to escape. The second technique can be combined with the first after you free one of your legs, or it can be used on its own. You fall forward to spread your body weight over a large area. This helps to minimize the amount of stress you're putting on the quicksand. And then slowly move your foot free and crawl or roll away to solid ground. Do not have someone try to pull you out, for this risks pulling them in and possibly injuring yourself. Also, try not to waste your energy with unnecessary movements, because this only creates a vacuum pressure under the surface, which makes it harder to move and escape. Plus, exhaustion is one of the biggest risks of being caught in quicksand. Now hopefully I have cleared up some of the myths and realities of quicksand. Go physics! Until next time! Oh, and remember, I am better than Indy.